Okay, a meteorological balloon is filled with helium gas at atmospheric pressure. So we can draw a balloon and the pressure is 1 atm. Calculate the volume of the balloon. Okay, the volume of the balloon. What is the volume? Okay, if it is whole, all the gas from 25 decimeter cube of gas cylinder. Okay, so we have a gas tank here. Volume 25 decimeter cube and pressure is 150 atm. So, okay, we can give the condition in tank is condition 2 and also pressure 2. For atmospheric pressure for the balloon is P1 and V1. So since there are two what we say volume and pressure, okay, the change of volume and pressure right now, so we can use Boyle's law. Okay, Boyle's law is okay, simply write P1 V1 equal to P2 V2. Okay, you solve for V1. What is the volume in decimeter cube? Okay, then next, the question also asks, okay, what is the maximum temperature of the balloon that can stand at atmospheric pressure? Temperature that it can stand. So if you get the answer from volume at in the balloon at atmospheric pressure, okay, we say it is X, X. Okay, so you put here X. You solve for X. Then for this question next, we are talking about temperature. Okay, another variable right now, the temperature. So if we have the temperature, okay, if the filling temperature is 15 degrees Celsius, means that in the tank, okay, in the gas cylinder, T2 is 15 degrees Celsius. Okay, so this one you convert it to Kelvin. Okay, and you want to find T1. Okay, so since there are three variable right now, V, P, and T, V, P, and T, so we can use the combined gas law, P1 V1 over T1 equal to P2 V2 over T2. Okay, you solve the T2. So the answer for T2 should be in Kelvin.